different nodes. And it's something that, I mean, this is sort of trickery that even, let's say, as a production system like Triple O can also have. They actually have the same host name. And I mean, and the host name is configured with this configuration option called host. And I mean, as long as you have the same backend names and so on, you could actually pretend that two different Manila share services are actually the same. And the way Triple O does this is fine because they run the service active passive with the help of pacemaker. And so at no point are two different share services actually active. It's just moved with the help of pacemaker. The control is moved with the help of pacemaker and stuff. Now there is a desire to run Manila active for scalability reasons. We're currently running in most deployments Manila API and scheduler in an active fashion, but not the share service. And there are a lot of problems why this is so, and some of those problems have been listed down there. I think one thing that'll make Gorka wince, because I was reading his documentation on Cinder, is this way of doing active. The poor man's active is something that's really bad, and bad things can happen. And for instance, I mean, one of the things architecturally that we can't do at this point when with you using this configuration is tell the individual services apart. So there's no way to tell if one single service, I mean, one of the services in this active deployment has gone down because they all appear the same way with respect to their identity to the Manila database. So that's one of the problems. And the other problems that we have evolved over a period of time are listed in this Etherpad as well. One, the principal one is if you were to deploy the share service active, that also means that you're deploying the share driver active. So your driver should be cognizant and be aware that it's talking to the same exact storage system. And I mean, it must be, this thing that there could be another process accessing its, storage at the same time. And one thing for sure that happens is space and capabilities reporting. And we do this at a regular periodic interval. And that could be racing with each other. You could have a share service that is updating its capabilities, and then immediately you have another share service that's updating its capabilities and its space. And if one of them actually has the later information, but the update from the other one goes in last, it just means that you have wrong data for a little period of time. And this problem is there even without running active, I think, because do we? Well, we'll just talk about this from the active perspective. So these updates might race, and there's another problem that's there right now, which is pre-allocation of the space. So we are very pessimistic in the way we treat that space that's available. So the moment a new volume or a new share is being created, we reduce the amount of space that's available in the backend, such that the scheduler takes note that there is lesser space than we actually know from the backend. And the next time we poll the backend, we actually get the actual space statistics. But for this brief amount of time between two polling periods, when we get a new request, we acknowledge it with reducing the amount of space that's there, that's available, and then increasing the amount that's consumed and so on. Apart from this one capabilities polling, we have other things that we poll for in the share manager right now. We poll for share replication status. What this means is there are timer threads in the share manager service that read a list of replicas from the database and ask the backend, hey, is this replica all right? Is this replica all right? Is this replica all right? In a sequential manner. and the backend is expected to return very quickly with the status that of that particular replica, and that's how we maintain the health of these replicas via the API. The other thing that we poll for is share replica snapshot status, and this one is a little different because when we create a snapshot of a replicated share, we keep the rest of this. We keep a bunch of references to the actual snapshot as well as the snapshot as it is there in the replicated shares themselves. So in the primary share, you have the actual snapshot that probably gets done at that very instant. But then we want to know before we say that the snapshot is ready for consumption, that this snapshot has been replicated as well to its respective replicas. So we have a polling thread that asks the backend repeatedly if the snapshot is ready at the replicas. The third thing that we poll for is migration status. It is a long-running operation, so we have a thread that basically asks the backend repeatedly if a migration has completed. And although the migration itself can happen in the data service, where the background thread that initiates this request originates in the share manager service. These are problems that we've added with respect to with these different features that came in, and they are not compatible with active-active. And the reason they're not is because while these are all read operations, you're just wasting your time and energy updating the same status from two different backends, two different share manager services that are talking to the same exact backend. So that is one concern. The other concern is when we start up the driver, we take stock of our resources. And if there are any resources in transitional states, we go ahead and perform some sort of a cleanup. And this cleanup currently assumes that there is nobody else that is performing this cleanup. So if you have an active backend, two of them can be racing to go ahead and perform this cleanup. That's one concern. The other thing is ensuring share exports. We do that on startup or at regular intervals with respect to configuration changes. So if you made a configuration change and you told Manila that hey, the configuration has changed, we calculate a diff of the hash values, and we figure out that the configuration has changed. There's nothing that's kicking off Manila share. But when the configuration is changed, the backend driver is invoked to ensure that the exports are appropriate. And the third thing that happens at driver startup that is that does not consider active or does not play very well is access rule sinks. So if we were in the middle of an access rule operation and the share service just dies, and it's respawned elsewhere or it just comes back on its own, we reconcile these access rules. We call into the share driver again and say, hey, can you go ahead and make sure that these access rules are all as per what the database expects them to be. So this is another operation that we probably don't want two different backend services to do at the same time. And I'll keep rambling for just another second and cover the last problem. The last one that we spoke about when Hayek Sheen and Bryn Zhang were around is another concern with active operations that take a long time. It ties in even with the cleanup operation that we spoke about on driver startup. For instance, you have a share that's creating, and it takes a while to do this create. Usually share creations are not that long, but if you're trying to clone a share into another, if you're trying to clone a snapshot into a new share or something, and you're doing any sort of data copy or anything that takes a reasonable amount of time, even if a few seconds or something, and your driver dies, your share manager service dies, or the node goes unresponsive, what happens? Currently, the share is stuck in creating, and until the share manager is restarted, we don't take any action on this. So we will need to work on cleanups for these long-running processes. And for example, share creation, extend, shrink, snapshotting, creating from snapshot, etc. And we haven't we that is something that we need to consider when we're dealing with this problem. So I mean, we have, with no further ado, let me introduce Giulio Fidente. He works with me, and hi, Giulio.
Hey guys, sorry, I wasn't on mute. I hope I wasn't making too much noise, but I think.
No, you weren't.
Okay.
Oh wait, I should pull your leg. No, that's good. And we also have Gorka. Gorka works on the Cinder team.
Hi.
Hello. So Gorka did almost all of the work that was there with respect to Cinder active. And when I say active for Cinder, I mean the API service, the Cinder volume service and stuff. So there's a ton of literature that he's put together with respect to his approaches to solving this problem in Cinder. And I did link a bunch of them that I found at the bottom of the page. And at some point, all of these were either written or reviewed by Gorka, and they're quite detailed.
I would like to start with the polling issue that you mentioned, that you could get multiple services responding to the same request. That if, for example, just to give context, in Cinder, what we did is we created an additional message queue. Like we have the normal host queue, we created one for the cluster. So there is a new configuration option, which is cluster name, which allows you to configure which host belong to the same cluster. And then the Cinder services, when they start, if they have a cluster name configured, they create a specific message queue for that cluster. They are created in the exact same manner as the normal host ones. So you have a broadcasting address, a queue, message queue, and a unicast message queue. This means that if you want to do polling, if you send it to the cluster unicast message queue, only one will respond to you. So you don't have to worry about which one will pick it up. You don't really care. Someone will pick it up and will reply. So you don't need to do a leader election for that specific case. So that is convenient. And I think that resolves one of the issues that you were thinking of. It is different if the poller, the service that is actually running the poll, dies. In that case, you have to either have some kind of workflow that another service can detect that it's gone down, or a user has to manually retrigger it. I don't know exactly the flow you have, but the polling itself, the service that needs to answer, that part should be resolved with the message queues. These message queues are also pretty convenient because they don't introduce that much change, and they ensure that they serve as a job distribution mechanism because they are round robin. They distribute via round robin. So you have, for example, 3 services. So they are listening to the message queue. You send one message, making an RPC request. One of them picks it up, starts working on it, and then the second one is now the one that will receive the next request for any RPC call. This is an easy thing to do, but it doesn't ensure even distribution of work. So there are easy operations and there are complex operations. So you may be unfortunate that the same node receives all the complex operations and the other two services are idly just doing nothing because they only receive easy ones. That is something that we consider in Cinder, but we decided to ignore it for the time being because it is something that can be built upon because we didn't remove the host message queues when we added the cluster. So when you have a cluster, you have a cluster address, but you also have the individual host addresses. This means that if later we want to build a better distribution mechanism that takes into account the workload of each operation, we could do it in the scheduler. So that is how we did the job distribution. So if you're electing a leader anyway, Tom, then sure, you can send all the requests to the leader, but then you're not distributing your work. And in this case, you don't care who answers, right?
Yeah, I get the idea that you're distributing the work somewhat randomly. That's superior in that respect. Just trying to understand.
Yeah. If you have a leader for other operations, you may, for example, leader will be convenient for the other problem you mentioned earlier, which is you send the stats reports from your shared services, and you only want one to be sending them. You don't want 3 services sending the stats. First of all, because they are usually expensive to get from your backend. If you're calling to see available space or you want only one to do it. In Cinder, we didn't resolve that problem yet. What we did was change how we reported the status, and we basically timestamped it, and the scheduler could check the timestamp and drop the older ones and only leave the newer ones. But if you already have a leader elected, it is best for that to be the only one retrieving the stats.
Yeah, definitely.
Yep.
No, go ahead.
No, I was just interested into the API race conditions that usually arise. I remember this topic was brought up a long time ago. I mentioned how we resolved them in Cinder, which was with conditional update mechanism, which is basically an update, a SQL construct that is update, set, where, and you set the clause. But if I remember correctly, the Manila case was a lot more complex because you had to query a number of tables. It was not possible, and you decided to go with the distributed locking, if I remember correctly. Is that still the case?
Actually not. So we do have updates set where in a more primitive fashion, but only for one operation, I think, and that is access rules. And technically, we did not encounter any other racy operations at that time when we started working on access rules. Access rules was like for us as big a problem as Cinder attachments were. You could have multiple requests coming in at one time, and then backends. Actually, it was a very expensive process to create new export rules. So we used to batch them up, and we would call the backend once. So for that, we implemented an update set where mechanism. So we basically queue the rules as they come, and while an operation is going on, we just say, okay, any new rule that's there, it's just going to sit queued until the operation returns, and then we're ready to process the next batch.
But in general, I think Gorka is right that in general, the approach that in the API that Ben led us in was to use an ing state in the database and to protect the transition to the ing state by means of a DLM lock. I mean that was the idea, and that his point of view on this was that we were going to get stuck relying on a DLM for other reasons anyway. So let's just do that for those. I'm not disagreeing with anything Gotham said about the access rules, which were really a more complicated kind of race than these ones that can be protected by a ing transition. Is that right, Gotham?
Yeah.
Do you okay, cool.
Yeah. No, you're right. And for us, I think the ing state would address one concern, which was, doing snapshot operations on a given share. We did not have anything that locks that share down when a snapshot's being taken, and if that operation takes a while, then we would be using a microstate to control that a share doesn't get deleted or get expanded or shrunk or something like that while a snapshot is getting this thing. We haven't implemented that.
And the microstates would keep us from having to hold a lock for a long time, or ideally hold it across service boundaries. So we're using database exclusion in those cases. There are maybe some cases where we are still holding locks across service boundaries, by the way, but that's a cleanup issue, I think.
Mm-hmm. Okay. Yep. Sounds good. Yeah, I remember your updates in the database were a lot more complex when I looked at them, and yeah, it seemed the better approach, that one. For Cinder, it wasn't, because I did some performance tests with 3 different approaches, and we went with the most performant one. Yep.
So at that time, you did consider using a DLM within Cinder as well?
Oh yeah, let me paste. What are you exactly writing in the doc? Well, I just pasted here. Yeah, that is some tests I did with 3 different ways, using a DLM, using a select for update, and update set where. Those were the 3 ones.
Okay, that would be cool to take a look at. I think I read this at the time that you wrote it, but I'd go back to that and take a look again.
One thing I'd like to go back is the scheduler part. You mentioned that I think it was inherited from Cinder. The part where when you create a share, the scheduler reduces the available space, and then with a pessimistic approach or a pessimistic estimation, and then it gets updated when the backend reports the next stats. Is that correct?
Right. Yes.
Yep. That is a problem we also have in Cinder, because that introduces basically unexpected behavior in the scheduler. So just send one create request, API request. The first scheduler gets it, reduces the amount of its available space. Then you send it again, and it goes to a second scheduler. We didn't update its internal status. So it allows it. Then you go make the request again, and goes to a third one, which also doesn't have the internal state updated yet. If you go and create a new one, make a new request, the fourth one may go to a first service, which already updated, and suddenly rejects a new volume creation until it receives the update from the backend. This is a problem with updating your local view of the world in one of the services and not propagating it to the others. That is something that we still have in Cinder, and we are looking into different ways to do it, but we are most likely to go with setting this stuff in the database instead.
Okay.
Instead of reporting via because the solutions I think we came up was we either keep track of this in the database, or when one of the services updates its internal view, it must send a broadcast to all the schedulers to tell them that it has reduced the available space so that the others can update as well. This is a minor inconvenience, but it's something that I've seen customers complain about. Like, hey, a scheduler is doing weird stuff. Like, it should be failing, but it allows me to create 2 more volumes when it should fail. So yeah, that is something to take into consideration, or at least have it, just take into consideration, even if you decide not to resolve it yet.
Yeah.
Because it will not be worse in active-active than in active-passive. It's something a problem you already have. So yeah. What else?
So this stuff with polling and clustering, what does polling in Cinder? Is there something that initiates the poll? Is that the scheduler service?
We don't have polling. We don't have polling in Cinder. It's just that you mentioned that you have that problem, but that is not a problem if you use the cluster message queue. You just send it. In Cinder, we would have basically, let me see. We end up with, I don't know if we have a job description. Okay, let's see. We end up having this. Let's see. Yeah, we would have like this. So we used to have, let's say, just host 1 at backend and start, and then the pool. Now, if it's in a cluster, we have one message queue with the host, another with the other host. They must be different, and they usually use the host name of the proper host. And then you have a cluster that is also reflecting the backend and the pool.
Yeah.
Because it must still be going to only those processes. So this is what we end up with. And if you want to do the polling, you just send to the cluster at backend pool, and only one will pick it up from there.
Yeah, that makes sense. I mean, if we were to initiate the poll from, as we are doing right now, on a periodic interval, which right now we have a periodic interval which we're doing the capabilities reporting anyway. So we could look into the database as well, and we could have something that says, hey, I've initiated a poll for this already. Don't look at this until the next polling interval at least. And I'm waiting on a heartbeat from the service that's updating the poll right now. And we will then, if we're implementing clustering, send a message to the cluster queue and let somebody in the cluster figure out the polling and then update the database.
So if I get it correctly, right now you have a thread that it's doing the polling, right? But who does the polling? In the manager, in the share manager, in the scheduler?
Yes.
So it's in the share manager.
Yeah.
Okay.
So we could keep that same thread in the share manager, except we would also talk to the database instead of just assuming that we are the ones that are going to poll the backend. But instead of before polling the backend, we could look into the database and see if another polling is currently happening, and we could implement some sort of a heartbeat that basically says.
But the polling, when does it happen? On a specific request? So I asked create a clone of a share, and then the operation is requested to a backend and then you poll it. Is that how it goes?
No. This is on absolute periodic intervals, just like the the capabilities update on absolute intervals. So,
So
and
it
I
is.
think,
Oh, I thought this was something that was initiated by the scheduler. Like the scheduler was polling the share service, but
yeah,
it's not, right?
it's not. It
Okay.
is initiated by the share manager on absolute intervals, and I think the shortest interval we have is 10 minutes, and the longest we have is 60 minutes. So there are different kinds of polls that are going on, each one of them at its own individual thread, and reading some
That,
sort of
then,
configuration.
then probably Tom's approach with the leader election makes more sense. Yes, have the leader do these operations, and you don't have to. That's probably easier to code, and it is easy to understand. I think
Yeah.
that is probably the best thing. Yep. Yeah, I thought it was the scheduler, the one that was polling. That's why I mentioned this just sending to the cluster
Yeah.
queue. But if it's the manager itself, it's better to do it by the leader.
Yeah. Okay. Makes sense. But I did have some notes around leader election. And you and I spoke a bit about this in the past. I mean, we have some issues with leader election. We would, if we were to use TOOS and not implement our own leader election, um, because TOOS has different drivers that probably are going to do it way better than what we would, come up with. There's actually an issue of compatibility. I have a couple of links over there. Um, there is a set of drivers, and these are the APIs in the leader election thing, and you can see, the number of drivers that actually support them. So the Redis supports it, Zookeeper supports it, Zake supports it, Memcached, but then we don't have support from etcd, MySQL, Postgres, um, and what else do we want to use? Maybe console or something. So we are limited by the number of backends, and we would now be making operators actually use one of these backends if they want the right kind of thing. We would have to implement it such that it works with leader election and it works without leader election as well. So without leader election, you have the problem that is there today, and which means you cannot assume to deploy your Manila share service active. And if you do have leader election, you would need to use one of these backends that supports it.
Yeah,
So
I
is
think
there any?
probably. Yeah, sorry, Tom.
Go ahead, Gordon.
Please.
No, it's okay.
No,
Go
I
ahead.
was just going to say that it would make more sense to actually look if it's possible to add it to some of the other drivers, like the etcd driver, for example, because I think it should be possible to add leader election to TOOS for that specific implementation. I don't think there's anything in etcd preventing us from implementing this. It's just that probably what they haven't implemented it yet. And it's probably a better approach to just use TOOS, say, and add it to the other drivers, or at least to some of them.
Yeah, I think we need a reference solution that will work, and if we can get it with etcd, that would be great. It would be open to other people to use a non-etcd solution for TOOS, but we can't boil the ocean and solve, test every possible TOOS backend and all that. If the world were converging around Zookeeper, I would say let's just test it with Zookeeper and go that way. But the world is not converging around Zookeeper for OpenStack right now. It's converging around etcd. So if we can do it that way, that would be good. Alternatively, perhaps there's some other open source standard leader election thing that's well accepted that's not even based on TOOS. I mean, we just need, I agree with you, Gotham, that we shouldn't re-implement inventing leader election. This is a well understood problem that's being solved by lots of people. So we could just be opinionated and have another dependency on something other than twos for leader election if there's a cool, I haven't researched this, but if there's a general thing that, everybody's using nowadays.
Yeah. Yeah, I haven't researched this either, but that is a good thing where we can consider in case whatever. Oh yeah, thanks for the link, Gorka. Calico using HCD for leader election. Interesting. Oh, cool. It's actually for OpenStack.
Yep, I think that's the approach that we probably want. See how they did it, and just see if we can add it to tools, to the HCD tools driver, and it should be done.
Awesome. Yeah, I'll definitely take a look at this and
because using tools instead of other any new open source leader election standard or something means that you will be using what Cinder is already using, what other OpenStack services are using, and what the installers are already deploying. So
yeah,
it will be less painful than trying to add it to the installer, trying to convince the community to use something different. It would have to be a lot better for the community suddenly to change, use something else.
Yeah, makes sense. I agree. There was something that I had a question about a second ago, but it's not coming to me at the moment. I think one other part was the only other project that I saw, at least on our internal code search engine, was Monasca. I think it's a metering agent. I actually don't know anything about Monasca, but they seem to be using leader election with twos. And it was pretty straightforward to follow their code to see what's going on. Yeah, that's. Well, the question that I had was, why would you still have the host message queues around when you have the cluster message queues? And what sort of operations would you want to directly talk to hosts?
Well, for one, if we wanted to improve the job distribution and we wanted the scheduler to be able to do something about it, being able to access directly a specific host is very convenient. Another thing that was helpful is we added a mechanism, the API, to change the log levels of the different services.
Yeah.
And also to query it. The querying help us like a rabbit and queue ping mechanism as well. So if you want to know the driver may be updating the database correctly, but suddenly it's not doing any work, and you want to see if the rabbit and queue is reaching that node, you can do basically a ping using the get me the log levels of this specific node, and then you get it. If you want to do cleanup a specific node to do the cleanup, you can do it. But the first way I did it was replacing, like using the same queue instead of having the host. using the cluster one, and I got a -2. Well, no, actually I got it almost approved. And then in one of the summits, they just veto. One of the courses said, no, this is not going in. So I had to redo it all. It was only like 20 patches. So awesome. No, it is the best approach in terms of flexibility for the future. And it's not like it's going to be a lot of cost in terms of the RabbitMQ to have a couple more queues that are mostly not going to be used. You know, they are mostly not going to be receiving new requests, so those queues will be mostly empty. Yep. I don't know who is sharing the screen.
It might have been me. Are you looking at
a blue screen?
a blue screen?
Yep.
Hopefully someone's laptop's not dead, but it could be me. Oh no.
Well, anyway, so yeah, for us, it allowed us to have flexibility for the future and not get stuck in something that later on we'll regret it, you know. And it also adds a big help, let's say, that we're going to have bugs in the code that parts of the code that are not taken into consideration that you have a cluster, and they will still be sending requests to the host.
Yeah.
You know, instead of sending it to them all, they will keep going to the specific host that created the resource, for example. So at least most of those requests, as long as the service that specific service is up, will get handled and will not just live forever in RabbitMQ. Because one of the problems that RPC through RabbitMQ, the way we do it in OpenStack, is that a lot of operations are asynchronous. So you just send a cast, and you don't know if somebody is receiving it or not. And if you send it to a queue where nobody's there, it lives forever. The message just stays there until somebody comes to pick it up, which can be problematic. So having the services respond to both helps with that, as long as the service is up, of course.
Makes sense. Wow, okay. So I have quite a lot of content over here, at least one action item. I didn't invite everybody, but I think I started a Taiga board with at least a few of you, and noted down a bunch of things that we were supposed to do, including setting up a test environment. And that's something that I wanted to ask again, Gorka, does Cinder upstream do testing right now, or is there some sort of how do you test with, multi-node dev stack or something like that?
That is the million-dollar question. We don't have testing right now, and there are two different parts to this problem. One is how do you deploy it, a multi-cluster service, or how do you run it? And a completely different one is how do you ensure that a driver is actually working fine in an active deployment. And this second part is really difficult, because each driver behaves completely different than the other. So, yes. For example, one of the places in OpenStack in Cinder, where we would have race conditions and problems between different volume services in Cinder would be when you attach a volume to a host. Mm-hmm. Because when you attach it for the first time, the Cinder driver will create a host entity in the backend with the ISCAS initiator name of or the HBA's identifiers or something like that. And if you only have one service, it may be using file logs or process logs, thing like that, and it's working fine. But when you add a second one, suddenly they would have problems if they both try to create that resource at the same time. Now, this is a problem for many backends, but for example, for RPD, this is not a problem. RPD, the initialized connection, doesn't do anything because the credentials are already in Nova, stored as secrets in QEMU and everything. So if I go and test RPD, that part will not be a problem, but for many other drivers, it will be a problem. And here is where testing, we haven't still gotten to a place where we say, if you run this set of tests with your backend, with your driver, and everything works, you're good to go. Your driver can support active-active. We don't have any way of doing that because each driver is coded different. Backends have different limitations, so it's not possible to give a single solution. As for deployment, right now there's an ongoing TripleO effort that Alan Bishop is carrying to allow TripleO to deploy it. So that could be the way that we will try probably to test it, because the alternative, when I tested this, I used two different alternatives. One was simply starting a different process, Cinder volume process on the same host with different host parameter. So in having both part of the cluster, and that allowed me to do some basic testing. And then what I did, which was a little more complicated, was basically a DevStack node and an additional DevStack node that only run the compute part. Yeah, the compute part. Well, the compute and the Cinder volume part.
Okay.
So, but the way we're going right now, or at least that's what I will be updating the documentation with for developers, is using TripleO.
Okay.
Because using DevStack is probably requires more manual steps.
Awesome. Yep. Thank you. That answers it. But we were looking at one of these approaches for CI. We did need multi-node for in the past for just testing replication in general. But then we worked around that by introducing backend specific availability zones. So right now we're able to achieve replication to multiple backends with just a single configuration file. You don't need multiple configuration files and stuff. So we kind of delayed multi-node dev stack testing. We have done multi-node dev stack testing in the past, but only locally. But I do know some other services that actually do multi-node dev stack testing. That's Nova and stuff. So getting the CI scripts should be straightforward, I think, if we can go figure out how they wrote it. But yeah, I mean, it's good to know what all has been tested and tried for Cinder volume.
Yeah, maybe, I don't know if somebody, for development, I will propose this, but probably, like you say, for CI, we'll probably have to go with the multi-node, which is probably less resource, it requires less resources than the TripleO approach in the gate.
Yeah.
So we may have to go with that as well. And I don't know if Luigi was going to be working on that, because I think he mentioned something.
Okay.
I will update you later when I will talk with him and see if he was working on that or if he had given it a thought. Oh, something else I wanted to mention is that in Cinder, we had some operations that had to be, let's say, how do I put it? Some operations had to be changed for active-active. So, for example, we have in replication, we have the failover mechanism. So, the failover in Cinder, what happened is we told the backend, okay, do failover of these volumes, start working on it.
Yeah.
That's fine. But now, when you have multiple nodes running the same backend, you cannot tell them all to do it because they will start fighting each other to do the same thing. And you cannot just go ahead and tell just one because the other services will be still going to the fail array. So you want to do the failover, the promotion of a secondary in one node, but tell all the nodes, hey, update your clients. You no longer want to go there. So what we had to do is for the replication, we added new methods and we added safety check that if you enable replication in active-active and the driver didn't have the new methods, the service would not start because it would say, hey, your driver does not support active-active replication. So please don't do it. So basically, yeah, we introduced a new method to the driver and added the checks to make sure that, yeah, nobody run something that would not work. And I don't know if Manila has such cases.
Yeah. Well, we don't support backend replication. We were talking about similar use case earlier today, but we kind of are pivoted that to volume groups or share groups replication. So there's nothing that's happening at a backend level itself. It's possible that a whole backend goes down in a disaster, but the control that users have is directly on the shares or the share groups, but not at the backend. And it's
so when they change. Okay, so when you access a share, if you have failover that share, in the next request, you don't need to change anything on your driver or on the running process. It will check where is the current primary for this one on each request and go there. Then that's great for you. Yep. That saves you from having to do that work.
Yeah. Cool. But yeah, I actually read this in your high availability doc. It was interesting, the changes that were made, because I did implement cheesecake, so I was like, okay, how does this work? So good. I mean, it was good for me to learn. Awesome. Okay, I'm done with all the questions, and there's actually an information overload in my brain, at least. Tom, did you have anything? Carlos, Douglas? Anybody else have any other concerns for Korka? Before I actually have a little more time, I think, to poke Julio about what's going on with driver, with this FFS driver, and how we plan to deploy that in an active-active fashion, which is kind of sort of related to this topic, but not exactly, because you could have a backend that's active-active. I mean, in a totally different sense, which is not currently the case. Awesome. I think.
Hey guys, I don't know where to start from though. I was hoping for some specific issue. But yes, I get why you're saying it goes into the same topic. the issue here will be that with Ceph and exports that are translated to NFS using Ganesha, we have a similar problem of running active the Ganesha instance, which somehow is out of control of the Manila pair service even, which is only really in charge of populating the Ganesha config with the new share. But then how Ganesha itself manages the translation into NFS, it's completely out of control of Manila. So I'm not sure how we want to approach this. During the real PTG, we went quite a lot into the details of
Okay.
how a latest implementation of Ganesha might eventually allow for more than one instance to serve both the same share. And I think we got stuck to more of a deployment issue where we really need for the client that can only have a single IP address to be able to reconnect when one of the Ganesha instances goes down and becomes unavailable. And the reason why I'm saying we went more into a deployment issue is that during PTG we were looking specifically at how Triblo manages the deployment of Ganesha, and that's currently, at least in the scenario deployed by Triblo, that's addressed by setting up a virtual IP address which is managed by Pacemaker. So clients and Manila do get a single IP address, which is their NFS server, even though there can be more than one instance of Ganesha serving that same share. I don't know. You guys guide me through the next topic or the next questions.
Yes.
We could go more into the details of the conversation that we had at the PTG and bring up the proposed solution for that, or we might look more at what is the issue with running a single instance. I don't know.
Yeah. No, that was going to be my line of question, because I know after the PTG with Manila, you actually had more discussions with the O team, and you had for addressing this. I mean, partially just to, I mean, we might have spoken a lot about this. Tom certainly has spoken at multiple occasions, including open infrastructure summits, about the proposed solution with respect to Rook and CephFS, using Kubernetes to manage HA and having active Ganesha service with that. Tom, if you can give us a link or something.
So, well, basically, I think one of the things, this will probably be an ongoing conversation and design issue that we won't settle everything on right now. But one of the things I wanted to do was make sure that Giulio meets Joss Colin and vice versa. And that we do that in the open in front of the whole community. They both happen to work for Red Hat, and this is an interest of Red Hat's. But Ceph and Ganesha and so on are not Red Hat only concerns. So we're having this conversation out in the open. NetApp guys might get bored by it, but or something, but it's it'll be part of the public record here that we're doing this. So our plan of record in the past was to rely on the work that is being done by the Ceph people to orchestrate the Ceph daemons and the Ganesha daemon via Rook Ceph and running in a Kubernetes context. Now, this was something that had some good momentum a couple of years ago, and the people working on it have basically aren't working on this anymore. They're working on Rook Ceph, but they're working on it in the context of a pure Kubernetes, not serving OpenStack. So also there's some reluctance for OpenStack deployers to use Kubernetes to manage these storage systems as well at the moment. So Julio had the idea, correct me if I misspeak, Julio, that we might be able to do active-active Ganesha without the Rook Ceph orchestration. That the Manila would interact with the Ceph backend using the active-active Ganesha work that Jeff Layton did, but we wouldn't have Rook Ceph orchestration around. We would still keep shared state for the active NFS in Rados objects. And then one of the, when we discussed this at PTG in the Manila session, we kind of got stuck on, well, if Pacemaker's not going to manage a virtual IP, as Julio indicated earlier, we have this issue that the client needs to maintain a mount to a virtual IP so that if the actual server behind it goes away and another one replaces it, it'll still have the same mount and be doing the same IOs. They'll just be blocked until the new server comes up. So if Pacemaker's not doing that, and if Kubernetes isn't doing that for us, who would? And then Julio had a conversation later after the actual Manila PTG session with some O folks in which he came up with a possible solution for that problem. Julio, am I framing that correctly?
Yeah. Yeah. Shall we go into the details of that conversation, or do we want to review what the situation?
Well, I think it would be good for you to
get in,
summarize your idea from talking with Damien and so on, for anyone who might be interested, and in particular, so that Josh can at least hear it for the first time, because we're going to need to have conversations with him representing the Ceph people or a representative of the Ceph folks going forwards if this idea pans out. Josh might have questions now, or he might have questions down the road, but we'll at least pose them in front of everybody. I'll shut up now.
Okay. Thanks for setting some context. Yeah. Well, so I only one comment about saving the state in RBD objects. I'm pretty sure, actually, because I've seen that's the same thing that happens when you deploy in containers using Kubernetes. So when it's Rook doing the deployment of the multiple Ganesha instances, it is the state in between the multiple instances is still saved in RBD objects because they're shared amongst the instances. But the problem with the IP is that when it's Kubernetes managing the deployment, then the hey guys, sorry, I went on mute for the problem with Kubernetes, you have an external IP which is created by Kubernetes, and which maps back a specific port to a container where a specific instance of Ganesha is running. And this mapping is maintained by Kubernetes itself. So when one of the instances of the containers, when one of the Ganesha instances dies, the container might be restarted or maybe started over on a new node, and yet the public IP of that mount remains the same because it's created by Kubernetes and maintained by Kubernetes, and it's just the mapping behind the IP which is updated to go over to the new node. So effectively, this to clients, effectively this looks like a virtual IP. You have a single IP and the mount is not changing, even though the container itself behind it might have been restarted or might have been moved over to a new host. And this is kind of okay when we do it with pacemaker, because the virtual IP will be shut down and moved over one of the instances where the Ganesha daemon is active. So it is I would say it's still behaving as you always had a single IP, but it's not really active, right? Like in that scenario, you always have a single IP anyway. But even if you have multiple Ganesha instances running, the virtual IP is always hosted on a single node. So they might be active in theory, but in practice, clients will always go to the same node when you use the virtual IP like that. So the proposal was mainly to have a local root on every compute node, which goes to the Ganesha instance and is not routed over a specific network, but it's just the same IP provisioned on every node, so that clients always have the same IP address, because that same IP address is always deployed on every node, but it's not rooted, and hence is always going to the local instance of Ganesha. Yeah, I don't know if what I'm
so repeat that part. This is the idea that you had for how to make
to make it actually active. Yeah.
Implement a virtual IP without pacemaker and without something like a Kubernetes service address, to supply it. Just say it again more slowly.
Yeah. So also maybe let me also add a comment about why the pacemaker solution is not good for active. I only mentioned that you have a single virtual IP which is maintained by pacemaker, and the single virtual IP can be relocated over to any node which is hosting Ganesha. But again, it's not active. It's always going, every request is going to the Ganesha instance, which is hosted on the same node where the virtual IP is, right? This is the main reason why the virtual IP wouldn't work for active anyway. So the proposal was, let's do something that looks like a virtual IP, but it's just deployed on every node which is hosting a Ganesha instance. And it's the same IP address, not a different IP address, on every node hosting the Ganesha instance. So that the amount that clients receive is always the same. They all get the same IP, the same amount, IP and share. And yet, it doesn't matter on which node the guest is actually spawned. We will make sure that IP is available on all nodes. And the trick is to make it non-rootable, so that you can deploy, configure the same IP on different nodes.
So
you're going to
Go
ahead, Gotham.
Yeah, so when you say it's deployed on every node, we're talking about compute nodes.
Yeah, so the initial, this was a left an open-ended conversation. It must be, right? The idea was this must be on every node which is hosting a Ganesha instance. And in the triple O scenario, this is not written in zones. Like you have composable rules, and you don't necessarily know which one will be hosting. But it has to be on the compute nodes because it's not rootable, right? The guests that are running on a given compute node, they cannot have multiple paths to go to the same IP address. So every compute node must get that request for the specific IP, and then if Ganesha is not there, it needs to get to one of the actual Ganesha instances, which probably something that will be done using OBS or one of the mechanisms that OBN actually allows for linking the bridges on different nodes.
So this way, a client will route to the server on the same node with this idea. The client's mount requests and packet requests for NFS will get routed to the server on the same node with this proposal. And if the client migrates to a different node for some reason, it's evicted or live migrated or whatever, it will connect to the server on that node.
Yeah. Okay. So I think it was not what the open-ended conversation was on if we can get encapsulation. So because you're assuming when you say it is on that same node, if we assume that Ganesha has to be on that same node, it means you have a Ganesha instance on every compute, right? And they didn't really want a Ganesha instance on every compute. So the open-ended conversation was how we can use OBN or Neutron so that the IP which is seen on every compute node is ultimately forwarding traffic to one of the nodes where the Ganesha instances are, and the nodes might not be the compute.
Oh, I didn't know that. Okay. I thought your idea was run a Ganesha on every compute. Is there and to do that at least initially in an edge scenario where there aren't all that many nodes. But is there an objection to running? Just so I understand, suppose we were to take a big scale out cluster and run a Ganesha on every compute. Is there a problem with that? I mean, that was Sage Weil originally had an idea like that a number of years ago. It wasn't going to use NFS. It was I forget the term right now, but it was like a VFS. I mean, VirtIO. VSOC, yes. The original VSOC solution he proposed back at the Tokyo summit would have involved running a Ganesha on every node. So I wonder if there's an architectural problem with doing that or not in a big scale-out cluster.
Yeah,
it might be, exactly. For instance, the central trust guys don't want that many Ganeshas running.
Yes, that was the topic actually, because so let's add some more context. The conversation was started around how we can get this to work in edge zones, right? And edge zones are not supposed to be very big. So for edge zones, having a Ganesha on every compute is probably fine. And the problem of getting the packets forwarded over to the Ganesha nodes is not an issue because you actually have Ganesha there. when there are more than, I don't know, 4 or 5 compute nodes, I am not sure anymore. Like, I don't know. I don't know.
Well, I'm not sure either, but did anyone
Yeah.
say there's a problem and argue that there's a problem, or just say, oh, it might be a problem?
Yeah, it was more the latter, like a general
Yeah,
problem.
okay. Yeah, so I think we need to find out from Joss and his people whether it would be are there scale limits here? If we have a small edge, this problem got pushed recently with us thinking about small edges that have maybe, say, 3 nodes.
3,
And where
5.
we're running, 3 or 5, something like that. We're running hyperconverged stuff. Nodes where compute and the compute clients and the servers are all on the same nodes. At that scale, I don't think anybody's particularly worried about running a Ganesha on every node. So a question for Joss and his folks would be, what if we were to do something like that, not only in the small scale edge case, but also in a big scale out OpenStack cluster? Would there be an issue or not? Sage didn't think there was back in Tokyo time, but a lot's changed since then.
It's probably worth to check that for Ganesh as well, because Ganesh, from Ceph perspective, Ganesha acts like any Ceph client, but is Ganesha really okay? In the scenario where you have like dozen of nodes sharing.
Well, yeah, I mean, it's more like Ganesha is a Ceph client, right? So, and it's so if you have the same chair showing up at different compute nodes with multiple Ganeshas managing it, and managing locks on it and so on, are we going to have potential issues or not? I don't know. I'm just trying to frame the question. Josh, does that make sense as a problem statement? You feel free to say no. I don't know anything you guys are talking about, and talk to me again about it later, whatever. But
I don't have an answer for that right now. I need.
No, I'm not
check
expecting an immediate answer. I'm just wondering, is the question formulated in a way that makes sense to you or not?
Yeah, that's right.
Okay, cool.
But Tom,
footnote is that on this is this we would be sacrificing an aspect of the Kubernetes based solution that we wanted. And I just want to be clear about this, is this does not yet get us to what we call DHSS equal true mode for Ceph, because we would be running Ganesha servers that are not specific to an OpenStack tenant. The promise of the Kubernetes orchestrated Ganesha servers was that we would be able to dynamically spawn them up on demand when a new tenant came along, the way you can do share servers for NetApps or EMCs or whatever. And this does not get us to that yet. So we remain interested in the other solution that Patrick Donnelly was pushing, and that I was pushing back a couple of years ago, when that gets back, when the Ceph team has some resources to move back at looking at OpenStack someday again, or rather, what they would call open, at the Red Hat level, Red Hat container storage with Kubernetes and stuff instead of just OCS with container with Kubernetes. What happened basically was that there was all these plans. Patrick can fill you in, Josh, but to do this stuff. But when OCS came along, everybody went off to work on that instead, which I'm not arguing with. But so that's why we're looking for a stopgap in the meantime.
I mean, I wouldn't see this as a stopgap because even otherwise, we needed a DHSS equals false scalable solution, right? We're not going to be doing away with the DHSS false implementation for SFFS, NFS.
Right. The other solution would have worked for both, though. It wouldn't have forced you to make a new one per tenant. You could have done both, but yeah, it's so. But you're right. It might not be throwaway work if you implemented this for DHSS equal false and thought it was good. Maybe it would be simplest just to keep it in place for that.
Yeah.
For one thing, the Kubernetes-based solution would be most likely to be something that would be done first with an external cluster, because it would not introduce Kubernetes dependencies in OpenStack at large. You wouldn't have to fight with the OOO people about how you deploy stuff and so on, or get into the slippery slope of people misunderstanding you and thinking you want to do everything with Kubernetes and OpenStack or something when that's not really being proposed. But so if it's an external cluster, then it's none of our business. It might as well be a NetApp or an EMC. Who cares if it's Ansible or Kubernetes or whatever that's orchestrating it. Okay, I'm digressing. Sorry.
Hey Tom, just when you said, "Is this a good answer?" I think we can probably put on aside the problem of decoupling Ganesha from the compute nodes, at least initially, and just focus on if there are scaling issues to see if we can come up with a number. Say, yes, this is okay as long as you have less than, I don't know, 20 nodes.
Sure.
So maybe
Sure.
maybe we know it's also easier to actually implement in OOO as a deployment scenario. So it actually gets us there with less, in shorter time frame. And maybe we can say this is okay for Edge as long as you have less than 20 nodes or something, but not for much more. I don't know.
Sure. I think that makes sense. I was kind of going off into all the bigger, more long-term issues. So I think if you can frame the short-term specific issue about edge deployment for Joss, and get that conversation going, and find out what the scale limits are, according to these guys, then we could look at the routing part on our own, as you say, because that's not a SAP issue. That's a OpenStack issue, OOO issue. Cool.
Yeah, we'll continue discussing.
Right. Is there anything else for Julio while we have him here? I think I certainly get a clearer picture of what happened at the PTG. Wish I was there. This seemed like a really interesting direction that we're taking, and it's a good thing for us specifically because we're looking at commercial solutions that are scale out because of the way they're architected with their storage arrays. But then to take our open source solution, which is production quality, and then build an architecture around it, supporting multi-tenancy and stuff, it's really, really cool. Anybody else has anything else to add about this? We've certainly run over into the next topic, but I wanted to get back to Gorka's question on chat, which is quite interesting, and we didn't actually bring that up during this thing when discussing with Gorka the cleanup mechanisms. Are there any questions about the cleanup mechanisms and stuff? Yes and no, I think. I mean, the yes part is what I see as cleanup is failed operations. And what I read as cleanup in your specs is about the workers table and how those specific operations are being, kind of recycled once a thing is done, an operation has completed and stuff. But
No, it's really the same thing. It's basically,
okay,
I think you mentioned it earlier as part as one of the things that could happen is that when one of the services starts up, so you have a service running, it's doing operations, suddenly dies, the share service, it leaves some operations in ing state, like I was deleting, I was creating, I was doing something. So when
yeah,
it starts up, it goes, and I believe you do like Sinner does, you check what resources belongs to me, which ones were in ing state, and how can they clean it? How can I clean it up, right? If it was
yeah,
deleting, okay, I delete it again. I try again to delete and things like that. That is fine when you only have one service running, but if you have multiple ones in a cluster, you may have requested a different node to do the cleanup. Like node 1 goes down. It had some operations going on. So now you go and say, start cleaning up whatever node 1 left there. In node 1 now comes up. So now you have two nodes doing the cleanup. The one you requested and the service itself in the startup. So you have to take that into consideration, that having a cluster means that you will want other nodes to do cleanup as well. That is why we have the workers table, which I can assure you it's the worst name I could have given to a table.
okay.
I did it, sorry. So, yeah, Tom.
So if we have a table, whatever you want to call it now, that shows who was doing cleanup or who is doing cleanup, and we have some way of deciding that that guy is dead and somebody else ought to do it, and we use something like leader election or whatever to decide who the new responsible party is. How do we have to do some kind of fencing or shooting the guy in the head who was doing it so that we know that we don't actually have two people messing with the back end? I mean, this is more general than just cleanup.
For cleanup, we didn't want to try to make Cinder too smart because it gets hard really fast. Like you say, how can I be sure that the other node is down? How can I be sure that I have to choose somebody else to clean up? So what we did is we didn't do any smart stuff. We just let the operator decide when to do the cleanup. So what we added is a way for an operator. They have a way to check when a service is up, which is something that I didn't mention earlier. That is something that needs to be changed in the code all around, because prior a service was up when you have the service up, but now service itself is up in a cluster when at least one of them is up. So what we gave the users, the admin, is a way to check, is the cluster up, and also which of the services are up. So, oh, this service has gone down. So I go and actually check, confirm that it's down. They do it however they want, and then they can trigger the cleanup operation. So they say, okay, I have confirmed the node is down. Let's start doing the cleanup. And since we have a table with the workers table, which each one of the operations that are in flight, when we go and do a cleanup, we go one by one, and we get one, and we say, okay, I'm working on it now in the workers table. So if somebody else tried to do the cleanup, they will notice that somebody else is already doing the cleanup and go to a second one. So we use that table to reflect what is in flight, but also to serve as an exclusion to who is doing the cleanup of each one of the rows. So worst case, you request the cleanup, one of the services starts doing the cleanup, and the service comes back up. Okay, it comes back up, and it will use the same table to do the cleanup, and it will try to do the cleanup of the first entry and see, oh no, somebody else is doing the cleanup. Let me try with the second one. So they will just be fighting against the same table, but only one of them will actually perform the operation, because they do a conditional update saying, okay, the host that went down is host 1. The operation was being done by host 1, then I want to clean up. So I say, as long as the operation was being done by host number 1, do change the update and do this. I don't remember the exact code that I added, but it was basically conditional update on that one. So they don't race to the same cleanup. Instead of having a leader election, the cleanup, I did it that way because I didn't want to introduce the dependency on the tools driver for leader election. But if you already are going to add it because you need it, you are going to want it for the polling, maybe you can already change the way you do the cleanup and use the leader to do the cleanup. When you request the leader, the cleanup, it is the leader, the one that does the cleanup, for example.
Yeah, maybe so. But explain to me, apart from the question of whether you use the table exclusion or the leader election to settle who does the cleanup, what are we doing with if node 1 was doing the cleanup and node 1 goes away? You say the operator is now going to do something to declare that node 1 is dead, and
they don't declare them, they trigger the cleanup. The cleanup is manually triggered, and they must filter what they want to clean up.
So one cleanup was in process, and node 1 dies. Node 1 was doing some cleanup, and node 1 dies in the middle of that cleanup. The operator notices that node 1 is dead, or is alerted to that or something, and triggers another cleanup. Now, that starts a brand new table in your scheme?
No, the table is not created when you request a cleanup. The table exists and gets entry per each cleanable operation. So if deleting is cleanable when the the delete operation is received by in your case, the share manager, it updates the entry. It creates an entry in the database saying, hey, I'm doing this.
So now node 2 starts working through and sees that a particular cleanup item is in the table for node 1. But node 1 is really dead. It will never be cleaned up until node 1 comes back, or what?
No, what you do is, okay, so node 1 was doing cleanup or doing whatever. It doesn't matter. There's no difference if it's doing cleanup, because what it's doing is in the workers table, it has a number of rows saying, I am doing these operations. I am deleting, I am creating, and I am cloning. That is what I'm doing, or creating volume from image. So, so what they do is, this is what I'm working on. So when I die and the operator says, okay, please, somebody else start cleaning node 1, what the other services do is say, okay, let me filter the workers table with what was node 1 doing. I filter it, and I start working one by one and doing atomic operation on each one of them to claim them. So now I claim, hey, I'm working on this one. I'm working on this one by one. And by claiming each one, if somebody else starts cleaning up as well, they will collide the claims and there will be a winner. And the other one will say, okay, somebody else is cleaning it up. That's fine. I can go to a next item. So it's not a cleanup table. It is an in-flight operations table, but only adding operations that are cleanable. If an operation is not cleanable, why add it?
Thank you for repeating the explanation. I think I understand it this time.
Yep, no problem. And I think I have probably some blog post or something of how it looks like when you check, because for cleanup, what I did was make it possible to request cleanup not only by node, but also by resource. For example, only cleanup volumes, only cleanup a snapshot, only cleanup this specific volume. So you can actually filter what you want to clean up and whatnot. In case you want to try things and go one by one manually or anything. Yep. So in your case, you may be able to do something simpler and not require this additional table. You know, you could, for example, do the leader election and have the leader always be the one doing the cleanup and nobody else. I don't know.
Yeah, maybe. Depends on how.
So you have more options, and the workers table is a lot of work. So I would explore the leader solution first.
Yeah. Makes sense. I did have one last question though. So if I mean the operator playbook seems to be look at the service table, see I mean if the cluster is having some issues, that is some nodes are down, then you go ahead and initiate cleanups so that if there are any in-flight operations on those nodes, they get cleaned up. That's the thing. So is it not feasible for somebody to just automate this and just run this as some sort of a job?
But how can you be sure that the node is actually gone? Because you can be having problems accessing the database, the heartbeat going through the database, and that's your only problem. Everything is going fine. So you can automate it, but if you automate it and you make it wrong, you start messing things.
Yeah.
So to me, it made more sense because that can only be done at a later time. for example, add it in the scheduler or somewhere else to do it. But for starters, my experience is that trying to make Cinder too smart introduces a lot of bugs. So
yeah, we should follow Ben Schwartz's idea and Schwartzlander's idea in the storage SIG Kubernetes of having the back end actually fence off, in this case, Cinder or Manila drivers, nodes. In other words, because that then it's not Cinder or Manila being smart. It's the back end saying, "Oh, I got an order to stop listening to that guy. I'm going to do it." I don't know how that's going to play out, but it's potentially a way to do it without actually having to decide to kill off a node or something. Just a side remark.
Yep.
I'd like to see how that plays.
Okay. Awesome. I'll have to interrupt this. This was a really lively discussion, but at the same time, I think we're going to be losing a few people at this break, and we should take this lunch break. That's at least in your time zones, Tom, Vicky, Vida, and Carlos, Douglas, all of you. So thank you so much for joining us, Gorka and Julio. This is probably one of the best discussions that we've had about this topic in a long time. Now we got to actually make sense out of this and draw out some action items. We'll keep you in the loop with the way we're planning this and how we implement this. Awesome.
Yep.
And at this, thank you.
Thanks, guys. Thanks, Gorka, actually. He did all the work.
All right. Have a nice day. See ya.
Yeah. Thank you. See you. Josh, were you going to join us after this break? I would think not. But...
I don't think so.
Yeah.
It's been very tired for me.
Oh, absolutely. Yeah, it's 10:30 p.m.
Yeah. The problem is I used to wake up very early, like 4 a.m. in the morning, and then so this seems to be too late for me.
Yeah, absolutely. Yeah.
So I think I'll go and take some rest.
Yeah.
And thanks for coming
You're
and
welcome.
introducing yourself to everybody.
You're welcome. Bye.
Yeah. Take care, Josh. Good night.
Bye.
Cool. For the rest of us on the call, we will be taking a lunch break or whatever break in your time zones. For me, perhaps a dinner break. And we will be reconvening at, it says 17:20 over here, but since we ran over, is 17:30 UTC good?
Yes, I think so.
Yeah, sounds good.
Oh yeah. Hey Vida, we can finally hear you.
Hey. Yeah. Hi, everybody.
Hello. Awesome. Cool. We'll reconvene in about half an hour, and I promise more breaks more often. We only have to plow through a couple of topics, and although we lost our critical mass, because this meeting is recorded, we will certainly be getting probably post conversations on this. I won't stand between your lunch and you. See you guys in half an hour.
See you.
See ya, bye.